Let's now have a simple example on statement coverage. If day equals Monday, then statement A, else statement B, and if. So this is our first if statement. The second if statement, if day equals Tuesday, then statement C and if. So here, our day has many choices. It might be Monday, it might be any other day, and it might be Tuesday. So one might think, okay, we have 3 test cases. The first, the day is Monday. The second is any other day, let's say Saturday, and the third is Tuesday. Do these 3 test cases perform 100% statement coverage? The answer is yes. But is this the best way to perform statement coverage? Like we always say, we need to perform 100% statement coverage with the least number of test cases. So here the answer is no. We can have a less number of test cases to cover this code. Here the else statement B. It means that in this statement we can have any day of the week other than Monday, okay? So what if we think of only 2 test cases? The first has the day of Monday and the second in which the day is Tuesday. So here we have only 2 test cases. So in the first test case, if today equals Monday, then statement A, okay, else statement B. Let's take Tuesday and pass through the code using it. Is Tuesday equals Monday? No. So this will go through the else, okay? It will go through else and perform statement B. Then, if today equals Tuesday, is today Tuesday? Yes. Then it will perform statement C and end the code. So this is more efficient, only using 2 test cases. Let's now try to perform statement coverage on this piece of code. So here our code says start do until B equals C. What is the meaning of do until? He means that do this code, okay, execute this code as long as B is not equal to C. If B is equal to C, this code will not be executed. So do until is equal to, for example, if not. Okay, it is similar to it. It is not the same exactly, but it is similar to it. Okay, so here I will do this code as long as B is not equal to C. So what is my code? If today is equals Monday, set A equals 1. Else if today equals Wednesday, A equals 2 and B equals C. And if, so this if will end here. And we will begin another if statement if B is smaller than C, B equals B plus 1. So how many test cases will be needed for statement coverage, and what are the inputs that will be used in these test cases? Okay, so first, in order to execute this code, I must make B not equal to C, so that I go inside this code, okay? Here I have an if statement, and this if statement has 2 decision outcomes. Today equals Monday and today equals Wednesday. So I must have a test case in which today equals Monday. This is the first test case, and I must have another test case in which today equals Wednesday. If I have these 2 test cases and they have the condition that B is not equal to C, then I will be covering this piece of code, okay? Then we have if B is smaller than C. Well, I need another test case, a 3rd test case, to execute this part of code? No. Why? Because I can cover this part of code inside any of these 2 test cases. So here I have test case 1 and test case 2. Let's write them on the right hand, for example. We have the first test case, B is not equal to C, okay? And today equals Monday. So here I pass through this path. Okay, then the second test case, B is not equal to C and today equals Wednesday. Okay, and any one of the 2 test cases, I will make B smaller than C, not B not equal to C It might be greater than C or smaller than C. No, I will make it smaller than C. Okay, so in this case, let's trace our first test case. B is smaller than C. Start, okay, do until B equals C. B is not equal to C, so we will go through the code. If today equals Monday, set A equals 1, okay? Else if today equals Wednesday, today is not equal to Wednesday, so he will continue his code, end if. Then, is B smaller than C? Yes. Therefore, B equals B plus 1, end if, and end the loop, okay? The second test case, B is not equal to C, smaller or greater, then he will go through the code. Today equals Monday, no, he will go in the else, set A equals 2, and B equals C, and when B is equal to C, okay, so this condition has been met. Here, B equals to C, so he will not continue his code. He will stop here. He will not go through this if statement. And that's why I chose the first test case to make B smaller than C. And in this case, we covered 100% statement coverage of our code with only 2 test cases. In this example, we have a variable that is called quantity. If this variable is greater than or equal to 20, the discount will be 5%. If this variable, the quantity, is greater than or equal to 100, the discount will be 10%. So you as a customer will buy some items from the store. If you buy more than or equal to 20 items, you will get a 5% discount. If you buy more than or equal to 100 items, you will get a 10% discount. So how many test cases will be required in order to achieve 100% statement coverage? Any person who thinks about this example might say, okay, we have 2 if statements, so I will have 2 test cases. In the first one, I will think of a value that is greater than 20. In the second one, I will think of a value that's greater than 100. So for example, he might think of the values 25 and 105. This is an example. So 25 will pass through the first if statement and 105 will pass through the second if statement. But what if we think of only one test case? What if we want to achieve 100% statement coverage with only one test case? So I might think of another or a new test case. If the input, for example, is 105, let's go through the code with this input and trace it and see, does it achieve 100% statement coverage or not? So 105. Is it greater than or equal to 20? Yes. So I will apply the first discount. Then I will ask, is 105 greater than 100? Yes. So I will apply the 10% discount, and this is 100% statement coverage. So here I needed only one test case to achieve 100% statement coverage, even though my code contains 2 if statements.